Hi everyone, welcome back to the course. So in the last video, we had a pretty much just a really fast, like get it done kind of video. Just have some fun, get the code in there, get the code working. In this video, I want to go into more of a deep dive into what all of that code meant. So that's pretty much going to be the structure of these courses. Is if you just want to kind of quickly make the game, then watch the top level lessons. If you don't, and you want to get like more of a real overview of what this code really means and how it all comes together, then watch the deep dive videos, and you'll get a lot more content that way. So, without any further ado, let's come in here. We'll start with our game manager object, which is what we started with in the last video. And here we have our game manager script that we created, and we just dragged it on to this object. And you could do it the same way by just dragging it. It's the same as just dragging it right here, and it adds this script to the object. Now every script, everything that is added to an object in Unity is called a component. So this would actually be a game manager component, which is a script. The same goes for its transform. Any 3D object in Unity, even if it is an empty 3D object, will always have a transform component added to it by default. That is the only component that a 3D object will always have, as a transform component. And it makes sense because, if you want to exist in 3D space, then there's three things you need to have, which is a position, a rotation, and a scale. If you are missing any one of those, then you pretty much don't exist. Let's get into the script now in Game Manager. So the first one may throw you off a little bit. Public game object, brick object. If you're only used to working with primitive types or other libraries, you may not recognize what game object is. Game object is a class made by Unity, and literally all it does is it stores an object that will go into your game. So it stores pretty much what we would, I guess, consider a physical object in the game. In our case, it actually stores the brick prefab. So you come over here, drag it into the scene, you see this is our brick, delete that out of the scene, and here in our game manager, you see we have the brick object. Oh, wrong one. There we go. Drag it in there. And there we go. We now have our brick added to our script. We go back to our script. So we have 4 floats. If you don't know what a float value is, there's plenty of tutorials, even here on YouTube, that go over primitive types in C# very well. So I'm not going to explain what a float is, just know it's a decimal number. And we define our floats as min-y and max-y. So let's look at what that actually is by starting our game. Okay, so we'll start with min-y. And if you come up here, if you don't really know much about 3D, I guess I should go ahead and tell you that. We'll start by just coming in here and let's create a cube, another cube. Okay, so one thing that I like to do to remind myself what position in Unity at least is XYZ equals RGB. So X would be related to R, Y is G, which is green, and Z would be B. Now, in 3D, I'm sure a lot of people are used to working with two-dimensional graphs where you have your x-axis, which is horizontal, and your y-axis, which is up and down. And the third dimension would be z, which is if we were to take a pencil and stick it through the paper that you write your graph on, which is forward and backward, then that would be the z-axis. So now we know what x, y, and z are as far as up and down, left, right, forward, and back. So if we're looking at our y minimum and y maximum values, what we really want to know is what the minimum value any brick could ever be going up, or going down rather, and what the maximum value it could ever be going up. So if you see here, we're going to look at our min y first. So if you see here, the minimum value on the y-axis for any of these bottom row of bricks is going to be 2.8. And we know this because it's right here in our code. Okay? So with that said, we look at the maximum value as well. If we come up here to our game manager, we can see it as well. So we have max y, which is 6.4, and if we look at this brick, we know for sure it is 6.4, and you can click any of these, and it's always going to be 6.4. And then let's say we were looping at minus 0.4 on that axis. So if we were to come up here, it starts at 6.4. You go down to the next one, and it's at 6. So 6.4 minus 0.4 is 6. And then we can see it rings true, 5.6 and then 5.2. We skip one because of our randomness, and so on and so forth. So that's how we did it with our y-axis. For the x-axis, we have the min x and the max x, and this is negative 10.5 is our minimum x, and our maximum x is just going to be the absolute value of that. And you can see that that rings true. Our minimum value on the x is actually negative 10.5, and our maximum value on the x is 10.5. So that works. So the biggest question most people had was probably in this logic right here. Hopefully I don't have to explain what a function is and how to call one. If you don't know what a function is, just like floats, there's plenty of resources on the internet to go and figure out what one is, but just know if you want a function that does not return a value, then it's always going to be of type void, and then you just have your name, and then in here if you needed any parameters you would put it there, but for this one it doesn't take any parameters. So we start with our for loop, and this for loop, the top one, we start iterating on the y-axis, and that's why I named this float y. And we're going to start it at max y. So this float is now equal to max y, which is 6.4. And then while y is greater than or equal to the minimum y of 2.8, then remember we had to do this crazy math.round here for to get rid of that rounding error we were having, but pretty much all this means is y is going to be equal to y minus 0.4. And that's pretty much it for that loop, and we can see that it is, it's working. We start actually at the max y, which is 6.4, and we go down to 2.8, then we have 0.4 in between. So we know this is working. And before we execute any other logic inside of this loop, we have another for loop. So what this is going to do is we're going to define what y is, we're going to define what one row is, So right now it's equal to 6.4 if I were in the first iteration. And for x, we're going to iterate over everything on the x-axis before we go to this next y value. So we're going to define our first row, which would be 6.4, and then we're going to define every brick inside of that row until we go on to the next row. And we do that by just saying float x is equal to minimum x. So we're going to start with the left-hand side brick, and we're going to make our way up all the way to the farthest right side brick, which is while x is less than or equal to max x. We're just going to add 1.4f to that. And here we have our randomness functions for our randomness, and then we instantiate the brick right here. So in order to show you what this this nesting of the for loops actually is doing, I just want to come in here and actually just show you. So one thing you can do when you're coding in Unity, you can use the debug class. So debug.log would be the method we're looking for. And we could just say, I don't know, let's say x plus x plus that, and y plus y. Hopefully this looks kind of good in the console. Hoping it does. I forgot a plus sign here. Actually, I don't need it. Do need it right there, though. So this is how you can cannonate a string, by the way. You don't really need to know that. You can always use string.format, whatever, but it's just, I like doing it this way. Okay, so we'll just go ahead and run our game again. And start right here. There we go, console. And then we're gonna just come up here. We don't really need the game anymore. What we need is the console, and you can see all these messages coming up down here. If you double click it, it'll take you to this line of code that we actually just made. But what we want to do is just kind of inspect these. So you can see, I guess I kind of made this wrong. Since we're starting with y, we'll just go ahead and do y. Oops. All right. Since our first for loop is actually y, to avoid confusion, we'll just make this first log right here be y. So we know that this is our first block that we've laid. This is the first iteration of the code. So it comes from y is at positive 6.4, x is at negative 10.5, and we can actually verify this because we're setting y equal to max y, which is 6.4, and then we're setting x to min x, which is negative 10.5, and then we can actually come up here and look at it too, which is y of 6.4 and an x of negative 10.5. The next one we're doing, y is the same, it's 6.4, but x has changed, and we have added 1.4 to that, because, you know, a negative plus a positive is always going to be, you know, a higher number. So x is actually negative 9.1, and we can verify this as well. So we're at the same y, and we're at negative 9.1. And we're going to do that all the way until we get to positive 10.5. And then we see this. So here we have, this is the log that we made for our last x block, on this row at least. And we see it's a y of 6.4 and an x of 10.5. And then the next thing it's going to do, as soon as it gets done with this whole row, we are then going to decrement y minus 0.4, and y is now at 6. And we reset our for loop on the x-axis to be back to negative 10.5. And then we have y6 negative 9.1. Our randomness function didn't actually make it, but this is where it would have been if we hadn't, had a random function. The next one is there, though, and we can verify it. So it's x of negative 7.7, still that y of 6. And we just keep going down all the way for 10 iterations on the y, and I don't even know how many on the x. Somebody wants to count it, I guess you could, but I don't think it shows me. It says it looks like maybe, 20 or so. Either way, you see how it goes. And that is pretty much the explanation of the entire nested for loop that we've just made. Hopefully everybody's still following along. A lot of this stuff, it makes sense inherently to me because I've been doing it for so long. Please, if I am not explaining something well enough, please, by all means, definitely leave a comment. Let me know, and I will either comment and let you know, how to fix it or whatever, or if it merits it, I'll even create a whole new video in order to, rectify the issue. Okay, so moving on, the last thing about this is going to be our randomness. So we're declaring an integer, which is actually from system. This is a primitive type, but we're using unityengine.random.range. Now, normally, if we hadn't imported this system class up here, and the only reason we imported this system class is so that we could do this math.round. If we hadn't imported this, we wouldn't have had to use the unityengine.random.range. But the reason we had to put explicitly Unity Engine right here is because system, and I can show you this, also has a random class. I don't think it has a range method. No, it doesn't. So you have to make sure that when there's two ambiguous references like that, you define explicitly where it comes from. And so all we're doing right here is we're using the random class, and then we're using a method within that class called range. And then, so as I told you before, whenever we come in here and we read the IntelliSense on this, it says right here, it returns a random integer number between min inclusive and max exclusive. So what that means is that this will be included in the random number that generator that we're going to create to get our random number. But this one, the max, is exclusive, which means it will be excluded from what we're going to be returning. And the highest number you can ever get from this range is going to be this number -1. So the highest number this will ever create, the highest number that rand will ever be, will be 100. And then if rand is greater than 15, so which means, give or take, 85 out of 100 bricks will get laid. Then we just use the instantiate method, which is actually a Unity Engine defined method. And then we just, the parameters that we chose for this one was actually the third overload of instantiate, which would be, it takes in the game object to be instantiated. Maybe it's the fourth overload, sorry. So it's going to be the game object that will be instantiated, the position that it will be instantiated at, and the rotation it will have whenever it's instantiated. And if you want to always make sure that your object is instantiated with the same rotation that the prefab has, then you just use quaternion.identity. And with that said, that is exactly how this entire make bricks function works. And to be honest, this is probably going to be the absolute most complex thing about the entire game. So if you're looking at this thinking, holy crap, this is already getting crazy, don't worry, we probably just did the craziest thing right here. So stick with it and we'll have a lot more fun later. Alright guys, see you in the next video.